We don't have a piston part, but essentially using tweezers and not hands like me. There's a little seal here that goes inside there. The filter sits on here. And again, everything has to be clean. You should wear latex gloves.
Is there a particular way it goes
On the filter?
Smooth side up.
Smooth side up.
Quite smooth, that's the non-hatched side. Kind of looks smoother than the other side that we call the smooth side.
And so there's a little piston that pushes the water through the filter. And just one other thing to keep in mind too is that you don't want to, you have to balance your volume that will go through that filter. So in other words, if you're working in very turbid water, you won't get much through the filter. So you need to be aware of that at the outset before taking off and trying to put 500 mils of turbid water through a filter. So you push it gently through, and when I say gently, that is important because it's much better to be a trickle than to suddenly push the piston through. You run the risk of breakthrough of particles if you plunge the piston really hard through that.
Yeah, and hold it upright.
Yeah, holding it upright will enable hopefully a fairly even coverage of material as it goes through that filter.
Is there an automated machine that will do that?
Yeah, there is in our lab. And we, at some cost actually, about 7 or 8 years ago, we got something that we could set up in the lab that would enable us to create a nice vacuum to do that. Nowadays we use piston filters just because they're really easy. You can filter immediately in the lab, and that filtered water, it won't stop all biological activity, but it certainly slows greatly biological activity.
So we'll be developing a very similar system for eDNA that's all disposable to avoid contamination. Would it be worth $5 grand to you to have an automated system for the field?
Okay, so it doesn't go like this, just in case. It goes like that, hold it upright, and you just gently push through the water, like so. These are called GC50s, 25 millimeter diameter point. I think it's 0.7 micrometer in that particular case. Here are the tweezers. And just be careful when you hold the filter that the tweezers don't go through or try to avoid the contact with the main part of these filters that's actually filtering the water. There's little pieces around the edge that you're better to hold with these types of tweezers. What we really should have actually is a nice set of flat and smooth tweezers than these actually. For me, but I'd suck up too much and then bring it up to the set volume, about 50 mils, upright, and then place this on.
Because when I do it, I only do about 5 mils, and quite a bit of that, like I do exactly that, but then screw in the filter, but then the first bit is just going through the filter and it sits on top of the filter paper between the piston and the filter.
You mean actually in the filter tip?
Yeah. So it's like when you're dealing, because the lakes we deal with, you don't need to get a lot of.
Like a little headspace in the filter holder.
Yeah. So I just unscrew it and then suck some air up and then just push some air through, so it pushes that little bit of extra water. But is that, do you need to do that? Or?
Yeah, I think you should. You want to get rid of the air, for sure. But my recommendation would be to 5 mils. I know that you're dealing with some pretty turbid systems, but the more the volume, the more the reliability that you have. If you filter in 50 or 100 mils, then a mil here or there doesn't matter. Whereas a mil at 5 mils.
Well, when we do our nutrients for dissolves, you can't even push 12 mils through the filter anyway.
That's right. Actually, if you put too much through, you've actually got the other end of the problem. You've got to do too many dilutions, which can cause problems too on the fluorometer. So actually,
Right. Let's
it's, kind of happy.
figure it out
Yeah.
before you